We're going to go over 1.1G, Congruence and Similarity with Transformations Practice. So we'll go through these answers real quick. First, and this is on page 29 in your books. First, it ends the way that the notes ended, right? Where we have to say what the transformation was and then determine if it was providing us with figures that are similar or congruent. Okay, so that's how we'll start here. For this first one, we've got two triangles here, HIG and then H prime, I prime, and G prime. We will say that that is a dilation because we can see that it is enlarging the shape. And remember, a dilation is where it forms two shapes that are similar. And then we have this rotation over here. So we're going to put rotation. We can see the original shape was rotated. That is going to give us two shapes that are congruent. If we go on down to the next one, it's again a rotation. It gets rotated. The original triangle. Rotation. And we're going to put that forms two shapes that are, or two figures that are congruent. And then I have this trapezoid that gets reflected over the y-axis. So reflection. And reflections give us congruent figures, just like translations and rotations. Speaking of translations, here we go. This trapezoid is just slid over to the right, so that's a translation. And as I just said, that gives us two shapes, or two figures, sorry, that are congruent. And then finally I have this rotation, another rotation. And as we've said, rotations give us two shapes that are congruent. Okay. All right, now, if we look on the next page, so this would be page 30 in your book, it says on the following coordinate plane, graph a rectangle with the following vertices. So let's just graph each of these first, and then we can answer the questions about it. Point A there is at -4, 5, so I'm going to go to the left on the x-axis to -4, and then go up to 5, and I'm going to make a point. Point B, or vertice B, is 2, 5, so I'm going to go to the right 2 and then up 5. So I've got A and B so far. Point C is -4, 1, so -4, 1 ends up right here. That's point C. And then finally, point D is at 2, 1. And now I have my rectangle. Okay, I'm going to switch colors so we can answer the rest of these questions here. Okay. First, it says, what is the side length of AB? So when I look here and I count from vertex A to vertex B here, I've got 1, 2, 3, 4, 5, 6. So we'll put a 6 there. What is the area of quadrilateral ABCD? Well, I already know this is 6, so we just need to figure out what the width is, or the height. 1, 2, 3, 4. It's a 6 by 4 rectangle. That gives us an area of 24. And we'll just put 24 square units. Since we don't have any units to use, we know area is always units squared. So we'll put 24 square units. Okay. All right, so here's where we have to do a transformation. It says translate the quadrilateral ABCD according to the rule, the original point here, and then add 3 to the x value and add 4 to the y value. So I know I'm going to the right and up. Okay. If I'm going to the right and up, I'll just do that for each point. I'll start with point A. I'm going to go to the right 3, 1, 2, 3, and then I'm going to go up 4, 1, 2, 3, 4, and this is A prime. A prime. Okay, I'll do that for each one of these points. So for B, go over 3, 1, 2, 3, and up 4. 1, 2, 3, 4. There is B prime. Do the same thing for C. I'm going over 3, 1, 2, 3, and up 4, 1, 2, 3, 4. That actually puts me on that same line that made up line segment AB. And then do the same thing for, oh, whoops, let's label that C prime. And then label or find point D. So I'm going over 3, 1, 2, 3, and up 4, which puts me right here. I've got D prime. Now I can connect those, right, and form my new rectangle. And this is why we read directions first. So some of you probably already caught that, but I was not supposed to label that A prime, B prime, C prime, and D prime. It says in the directions right here, label the new quadrilateral G, H, I, and J. So we'll do that in order. G, H, I, and J. All right. What is the area of quadrilateral GHIJ? We know that area, when we are translating a shape, stays the same. So I'm going to put, again here, 24 square units. What is the side length of GH? Now GH, if we look, is the same as AB, right? Those are corresponding sides. So if AB, we already listed, was 6 units long, well, we know that the side lengths stay the same. So side length of GH is also going to be 6. All right, and now it says rotate quadrilateral ABCD 90 degrees counterclockwise. Label the new quadrilateral. See, I'm going to read the directions first this time. Label the new quadrilateral MNOP. So what I'm going to do is go ahead and rotate this 90 degrees counterclockwise. So that means counterclockwise, I'm going opposite of clockwise, right? So I'm not swinging this shape down clockwise. I'm going up the opposite direction. I'm going counterclockwise. Okay, our rules for that, hopefully we remember, would put us with the new, and I'll use a different color for this one too. If we follow our rules for that, that puts our new shape, and I have to label this MNOP as being right here. And what I want to do is make sure that I label that correctly. So I've got M, hopefully that's showing up okay. N, O is down here. And P, yeah, that's showing up pretty good for you guys, good. All right, what is the area of quadrilateral MNOP? Remember, rotation, that follows under that same rule where the area is not going to change, right? So that's going to be the same. It's still 24 square units. What's the side length of quadrilateral MNOP? Which side length of quadrilateral MNOP corresponds to the side length of AB on the original figure? And that would be, I'll use my highlighter here. That would be this one right here. MN is the side length that corresponds to AB. So we'll list that right here. MN. What is its length? It's the same as the side length for AB because the side lengths stay the same. It's 6 units. Are the figures you drew congruent or similar? And explain how you know. They are congruent, and as we just proved, we know that they're congruent because side lengths and area, those are the two things that we just answered for all three of these quadrilaterals. Side lengths and area stayed the same. Remember, we would have put that they were similar if the side lengths and area would have been proportional, right? But since they were the same, we know our shape is congruent. All right, if you have any questions, make sure you ask your teacher.